let's pretend that it didn't happen. So I figured it out. I forgot to set the default name for default value of the name property. So if we open it in the Unity editor now, let's create a new step. Add behavior, my company, scale object. So we get our behavior here, but if you note that the header and names of the properties, they aren't quite pretty. So to prettify them, let's jump back to Rider and add a display name from the Innoactive Creator core attributes namespace. And the display name for scale behavior will be scale object, the same as its name that the designer would be able to edit. And also let's change display name attributes for target objects. And target scale properties. So if we open it again in the editor, we should get it. Yep. Now the header for the type of the behavior is right here, and there are some spaces between words in the names of the properties. Yes, of the behavior. Nice. So we got very nice behavior. We can set its values to whenever we want. We can save them, but there is a little bit of a problem. This behavior does nothing. So how can we fix it? So if you remember from the previous lecture, we have our entities, and entities can start activating, then they are active, and then they are deactivating. And also there is some very confusing interrelation between different levels of behaviors, like chapters can activate and deactivate steps one by one. And now let's peek into how it happens for the step. So for the step, the hierarchy is like this. So we have behaviors and we have transitions. And in our transitions, we have our behavior, we have our conditions. So for simplicity case, let's drop transitions out of the picture. Like they have their own activation and deactivation cycles, but they are always the same. They happen almost immediately, so it isn't something that you should pay attention to. So what happens when we enter the step? Let me draw some line and put it here, and add some text so it would look nice. And I will say that we enter the step. So when we enter the step, behavior 1 starts activating, and behavior 2 starts activating. And they activate at different, they finish their activation at different times. So one behavior can finish faster than another one, and from that point on it's active, but also at some point this behavior becomes active, and at this point let's draw another line. So let's call it O behaviors activated. At this point we start activating the conditions. So I make it very small because we recommend to implement no logic in the activating step of conditions. I will explain why it is the case in the next few seconds. So, but yeah, there is just one frame of activating, and during that time behaviors are still active, and after this short activation phase, conditions became active. And while conditions are active, the step checks for every single of them if it's completed or not. I will explain how does it work in the next chapter. Just that's enough for now. So once all conditions of one transition are completed, the step starts deactivating stuff. And yeah, of course, all this time behaviors are active. And let's stick it together. Yep. So at this point, another line. So all conditions of one transitions. In this case, let's assume that all conditions of the transition one has completed. All conditions of transition one. So at this point, again, very short deactivation for all of the for all of the conditions. Yes. At this point, behaviors are still active, and once all conditions are deactivating, behaviors start to deactivate. Again, deactivation for both behaviors can take a different time, and once all this is a very weird line, but anyway. So once all of the transitions, now all of the behaviors are inactive, at this point the step will finish, it will inform the chapter, and chapter will pick up the next step, and it will start all over again. Yeah, so what is important for us right now? Hmm. Yep, like this. So what is important for us right now is that activating stage of all behaviors happens before activating stage or active or deactivating, before we check for conditions. Yeah, before any condition. And the same with deactivating. Deactivating happens only after we have dealt with our conditions, and we, yep. So basically that means that if you want to prepare the environment somehow to let your trainee to do something, for example, if you want to enable some objects or maybe you want to scale the object up so trainee could grab it easier, yeah, you would do it in the activating stage of the behavior here. And if you want to do something after trainee has finished whatever he was doing with the step, you do it in the deactivating stage. So for example, if you enable the object, you can disable the object if you no more need it with disable object behavior. Or in our case, if we have the object, we can make a shrinking animation, so it wouldn't be just like this, it would be some animation, so trainee wouldn't be confused. So let's get back to our code. Mhm. So let's first implement new class. It will be a private class inside the scale behavior class. So tabulation should be like this. And let's call it activating project process. Is it type process? I don't think so. Yeah. So for that, let's inherit from the abstract class, which is called process. And this is the process over our entity data. Yes. So now we can implement missing members. So missing members is the process constructor, and for methods, again, I've mentioned them in the previous lecture. So every time we enter the stage, we start executing some of the methods. I will talk about it shortly. So what do we have here? First of all, we have our constructor. We just pass the instance of the data. I will explain it a little bit later to process base class. So now we have 4 methods to implement. So first one is the start method. Start method is always called. It's called when we enter the stage. Here we don't have anything to do in the start, right? So for updates, every frame we have to. Alright, there is one more field that we forgot about in our entity data class. So how long would it take to scale the object to our target scale? So display name, duration, data member, and its public float duration get set. And let's set the default value to 1 second. So now what we want to do, we want to scale the object to our target scale over the duration. In the default case, it will be 1 second. Yep. So in the update is enumerator. For those who don't know what enumerators are, basically you can make a method, and every time you call this method, it will not start from the scratch, it will start from some point where it left in the previous iteration. So in our case, let's record the current time. So float time time started. Unity time. So in Unity, time is seconds passed from the launching of the application, and now we can write our cycle. So in every frame, so time, current time, time, yes, of course. So if time is while time is less than time started plus duration, data dot duration. So if you have noted, I just referenced the data property of the process, and this data is the same instance as the data in our behavior. So this way we can get access to duration field of our data. So while this duration is not elapsed, we can scale our object. So to do so, we have to remember the scale we started with. So vector free initial scale, and its data dot target object dot value dot game object dot transform dot local scale. So what do we do here? Let's figure out how much progress in percent we have made since the start of the application. So what we do here is equal difference between current time and time started divided by data duration. So if we, in the first frame, the difference between the current time and time started will be 0, we divide it by something, we get 0. But if we say if we have duration of 4 seconds and we are on the third second, so we get the difference, it's 3 seconds, we divide it by duration, we get 75%. So that's what we want. And now we can set the scale of the object. So data, target object, value, game object, transform, local scale equals to vector free lerp. Lerp is linear interpolation. It's a basic mathematic function, so you know where to Google. So what do we have here? We have our A, which is initial scale, and we have B, which is data target scale, and we have progress, which is between 0 and 1. So now every frame we will, right now, not every frame, right now the cycle will just go and go, just like normal method would do. So to fix it, we have to write yield return null. So we execute it for the first time, we get to this line, we return the value null. The next frame, this method is invoked again, and again, and again, and again over the further frames until we reach the time where it's over our duration, in which case we will skip this cycle and we will go to the end of the method. And when the entity will detect it, when the lifecycle will detect it, it will call the end methods of this process. So in this end method, we will just set the data target object value game object transform local scale to our data dot target scale. This is also useful because here we will not set the scale to our target scale. Yeah, it will be always something a little bit less. Yeah, because the chances that uh, that the time will be exactly the time of the train of the duration is fleeting, because that's how frames in Unity and I guess in the real life work. So every frame takes some part of the second, and you can't execute a method at some exact milliseconds, yeah, nanosecond, whatever. So you will always be either a little bit earlier or a little bit too late, and you will just never hit the spot. So for that, we will write it in the end method. So when we finish iteration, we just scale it up exactly how we want. And now the single method that we have left is fast forward. And so for, yeah, basically fast forwarding is like, for example, if you execute the training and then trainer clicks the button skip to the next step. In this case, all uh, uh, all entities which execute some process will call the fast forward method, and basically this method has to handle the situation uh, that would happen if we don't execute this method fully, completely, or at all. So yeah, for example, we just enter the step, and then we immediately receive this call. In this case, not a single frame of the update will be called. So to handle this situation, basically we can handle it as end method. So just copy paste it here. But the thing is that end method is guaranteed to be called. So there are two cases. Either we invoke start, then we invoke updates uh, again and again and again and again until we completely finish the update. And afterwards we call the start, the end function, or we call the start, then we receive fast forward immediately, and then we call the end method anyway. Or we invoke the start, then we invoke the update method for a few frames, and then we receive the fast forward call again. And anyway, we will call the end method. And since they are kind of duplicated, in our case, the fast forward method can be very simple. It can be empty. So it's completely normal. So in some cases, you will have empty update. Yeah, if you do something that happens only in a single frame when you enter the start. Or for example, if you if you have empty updates, then you would have empty end as well, because yeah, you don't really have to do anything to handle the situation when the update is not called, because it's normally not called. Yep, that's it for the activation process. And now we have to somehow pass it to our behavior. So to do so, we can override one of the methods, and in this case, it will be get activating process. So return new activation process. and pass the data. So yeah, so yeah, in our behavior, in our entity, we have a reference to data which is defined in the base class. So, and it's created in the base class as well. So we just call this property and we pass it to the activation process constructor. Note that every time the get activation process is called, it will return a new instance. And this is intended to prevent some cases when like you set some value, you save some value inside the process, which you should normally you could do, but I would argue that you shouldn't do. Yeah, and then you call the same instance of the process again, and it breaks everything. Yeah. So we got behavior that executes before conditions. So if we want to implement to do something after the conditions, we can implement the public overrides process get deactivation process. And of course, if you want to do something while we are checking for the conditions, you could uh, implement get active process method, but I don't recommend to do it. It's not because it's something like silly or whatever. Probably there is some use case where it will be useful, but we at Innoactive we tested it only once and we don't routinely test it. So implementing a behavior for with an active process, because again we are thinking that you either have to set up something before the conditions or you have to clean up after the conditions. Yeah, but not when transitions are working. But in theory, nothing stops you from doing something during the active stage. Just saying. So yeah, again, now let's get back to Unity. First of all, let's delete this implementation. Yes, so we have our activation process, we have our data. So if we open Unity again, nothing changes in the editor except for the duration properties. So let's say that we want to scale it to 10th scale over 1 second. And for object to scale, we can make a cube. Yeah, 3D object, cube. There it is. So, and now we can simply drag and drop this cube into object to scale. And we will get error. And we can fix it. So now our cube has training scene object mono behavior script. And now all what is left to do is to somehow launch the training course during the runtime. Yeah, because if we start the training right now, nothing will happen. So to fix it, let's add a new script to our, say, training configurator. And it should be simplest, no, course no, loader, no, runner, no. Yep, the script is part of our template. So let me quickly copy paste it from somewhere else, or just write it. So yep, let's create a new script in our template folder, and let's call it course loader. And in this script we will write it in such a way so if the script on the scene, it will start the training course which was selected in the menu in the during the editor time, uh, and it will execute it as soon as we start the application. So this time it's actually Unity model behavior. So this is a script that we can attach to other objects. Uh, so first of all, we want to get the. First of all, we have to implement methods. So it will be private void start. And in this method, first of all, we want to get the currently selected course, which will be runtime configurator dot instance dot get selected course. Then we can get an instance of that course. So we just got the course path which was selected by the training designer in the runtime configuration. Then we created a new instance from a serialized file by that path. And now we can feed it to the course runner. So first of all, we have to initialize it. And then we can simply run it. And from that point on, the course should start. So let's get back to Unity. It will compile it, and then we could add a course loader to the scene. So let's create an empty project, an empty object, and add component here. Course loader. Okay. So now when we launch the scene, so let's save the scene. Now when we launch the scene, we will execute the start method of this script, and it will take this training course. and it will start executing this course. And in this course we have our behavior, which will scale our object or not. Oh yeah, I forgot to connect start of the chapter to the first chapter, to the first step. So what happened here? We entered the chapter. We figured out that there is no next step, so we didn't bother to fix it, to execute it. So we just immediately finished the course. So now it should be fixed, and now we can run it again, and this time it should work. Yep. So let's try it once more. Yeah, there is some freezes in the very beginning because everything tries to load, like uh, Unity XR and so on. Uh, you could add this delay on your own, or you can just leave it as it is, because it's just an example of the code, and the code is working. And at this point, I would finish this lecture about uh, one more thing. So how do we actually want to share this? First of all, with XR bootcamp trainers, and second, or maybe in the other way around, with your designer colleagues. So what I would recommend to do is to either export your template as Unity package, and maybe provide all dependencies of it as a separate package, or maybe just pack both of the folders in the same package. So to pack something in the package, you can click with the right mouse button on it and click export package. Then you could drag and drop this package in your Unity project, and it will unpack these files in the same location as they were before. The second option would be to simply zip everything, everything you want, and to send it to the designer. Basically, Unity packages is pretty much the same zip files, but with a catch. And the last option, would be to make your own Git repository. We did it already just to import the core and components, but you can make a Git repository of your own templates and share it through Git means. The last note here is that when you import this Unity package, make sure that you deleted the folders that you are intended to replace, because consider this case. So you have some behavior in your template, and then you figure out that you don't really want to have this behavior in your template because it's like obsolete now, or by some any other reasons. Yeah, so you get rid of it. So then you pack the package, you send it to your trainee fellow, training designer fellow, and then he or she imports it into his project. And yeah, what happens there? All the behaviors, all the conditions, all the scripts are updated, but the script that you removed in your version of the project, it stays there. Yeah, because there is no way you can delete files with Unity packages, so you have to do it manually. Just delete the whole folder, re-import it again, it will work. So this turned out to be a quite long lecture, so thank you for your patience and passion. Have a nice day.